All right, here is the notes on sex-linked traits. This is when we have a gene and it is carried on the X chromosome. Not the Y chromosome, the female X chromosome. This occurs in different traits, but one of them that we'll talk about is hemophilia. We'll be learning different genetic diseases later. It also can happen in baldness and color blindness. So I'm going to add that one. Color blindness. So it's carried on the X chromosome. So we're going to be using X's and Y's. So remember, females are XX and males are XY. So I'm going to give you a little chart, and this is what you need to know. So draw this over here, or write this down over here. For females. Females can be X big H, X big H, which is a normal female. Okay, meaning she doesn't have hemophilia. This is for hemophilia, the H's. A female can be X big H, X little h. She is also a normal female. She does not have hemophilia. However, you can also call her hetero, right? And we're going to also call her a carrier because she is carrying the gene for hemophilia, but she's not expressing it. And then females can actually get hemophilia by having X little h, and so that is a hemophiliac female. I'm just going to write hemo, okay? So if you look at the genotypes possible, there's 3 genotypes possible for females. There is a 33.33% chance of a female getting hemophilia. All right, now for men, X big HY would be a normal man, or they can be X little hy. The Y chromosome does not get an H on it. X little hy is a hemophiliac man. So if you look at the genotypes for these two, there's a 50% chance of a man getting hemophilia. So in general, for sex-linked traits, men have more of a chance of getting these kinds of traits, like colorblindness and baldness and other ones, than females do. But females can still get it, okay? So let's try one of these problems. When you are doing a sex-linked problem, make sure you are always crossing a female with a male. And then for the X's, you need to put the letter that applies. So for example 1, cross a hemophiliac woman, she would be X little h, and a normal man would be X big HY. So the first box would be X big H, X little h, X big H, X little h, X little HY, X little hy. So notice the mom had it, the mom had hemophilia, and all her sons are going to get it no matter what. Her daughters are going to be okay, but they can carry them on to her grandchildren. So for phenotype percent, you're basically telling me, do they have hemophilia or no hemophilia? And I'm abbreviating that, okay? So what's the percent? You do not have to base it off of sex unless the question asks. So we're not going to do that. So 50% in general of their kids are going to have hemophilia, or this one's normal, sorry. These two have hemophilia, 50% no hemophilia. So these two have it and these two do not. For genotype percent, you're going to write it out. 50% X big H, X little h, 50% X little hy. Okay, let's try one more. Cross a woman carrier. So here's your woman. She's a carrier, so she's X big H, X little h. And she is mating with a hemophiliac man, so the guy has it this time. So X little hy. My first box is X big H, X little h. Second box is X little h, X little h. X big HY, X little hy. All my genotypes are different, okay? So it's going to be 25%, and yes, you would have to write this out. X big H, X little h. 25% X little h, 25% X big HY, and 25% X little hy. For phenotype, again, we're going to shorten that to say how many have it and how many do not have it. Have hemophilia and no hemophilia. So how many have the big H? 2 out of the 4. So 50% chance that their kids have hemophilia and 50% chance that their kids have no hemophilia. All right.